Okay, so for this part here, number 7 and 8, we want to identify the domain and range of the function in interval notation. All right, so we're going to use parentheses. We're going to use parentheses. Let me get my paper here. We're going to use parentheses and brackets, okay, or something like this with commas in the middle. All right, we're going to find the zeros of the function and then determine for which values of x the function is positive and which it is negative. Okay. Okay, so now I'm going to move this out of the way here. So we're going to do number 7 first. So I've got quite a few things here to talk about. Let's talk about the domain. So remember, we write the domain with a capital D and then an R. All right, the domain for number 7 means that we move from left to right. And as I move from the left to the right, I notice that my x values, if it's the domain, start at almost -5. So in almost -5, that means we go right up to it, but we don't include it. And this will keep going, and because there is an arrow and there's no point or a hollow circle, then we will say it will shoot off to positive infinity, and because you never reach infinity, you will always keep it open. All right, now the range of this function means what is the high and what is the low. Now, if I have a high, I always go from low to high. So the lowest y value, because this is range, is -4, and I do have a value at -4. All right, it's right there. Okay, -4 is there's no open circle there. All right, and then the highest value that I would have is actually going to be a +1. However, I feel, now that I just mentioned it, if this arrow keeps on going down, 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 that is no longer a min. I mean, it keeps going downwards, so actually it's not -4. This thing would actually go past -4 to negative infinity. So I'm actually going to correct myself here in mid-video and say that this guy actually goes down to negative infinity. All right? So the highest value will be +1, and the lowest value is not -4, but it's actually negative infinity because it keeps going. Aha, almost got me. All right, the next one is the zeros of the function. The zeros is where they hit the x-axis. So we will put zeros, and the zeros hit the x-axis at +1, zeros at x equals 1 and 3, and that's it. Now, when is this guy positive? Now, where is it above the x-axis, right? So that's a positive interval, and that would have been negative intervals, plural. So this one is positive from 1. Actually, it's 0 at 1, so we'll put 1 to 3. Okay, so that's parentheses. All right, and then it's negative from -5 all the way to 1. Okay, then it stops, so we have a jump, and then we're going to move from 3 all the way to negative infinity. I'm sorry, positive infinity. Okay, so that tells us where all of the negative values are right there. Okay, all right, now that's the story for number 7. So number 8 is going to be relatively similar. Here we go from the domain. We'll go in the exact order. Domain is going from -5, and we will not include that. We're going to go all the way to positive infinity. All right. The range in this case, notice how this guy slopes downward, right? Over here, he flattens out at the maximum value possible. So he doesn't just go downward. He goes straight across. This is the maximum value at +1. Okay. So I go from -4, and then I go to +1, and then I stay there. All right, there's nothing else changes. That's my maximum value. Now we go to zeros, okay, or x-intercepts, you could call them that. The 0 only happens at +2. Okay, you can see right here, +2. And then for the positive interval, that is everything above the x-axis, and it looks like we are at +2 right here. All right, we are ready to go above the x-axis right here at +2, and then as soon as we get past 2, everything else will be positive for infinity. all the way to infinity. All right, and it's negative basically everywhere else. We say it's negative from -5 all the way to 2. And again, you don't include, did I say -2 to +2? Okay, don't include 2 because he's neither positive nor negative. In fact, he's the 0, right? So these guys are kind of grouped together here. All right, this is where it touches the border. Zeros are where the transition from positive to negative actually takes place. Okay? All right, so now for number 9. Number 9, identify key features here. Now this was kind of tricky because you had to use these 4 facts here. And it's kind of, you really can't go in order here. We know that the domain goes from -5 to +5. So whatever I draw here has to go from here to here. Now it's decreasing from -3 to 1. So let me label -3. All right, I'll label those in here. So it decreases, but I don't know where it's actually going to go here. So I think I'm gonna hold off on the decreasing. There is x-intercepts from at -4 and -2, so that is here and here. So that's kind of nice. So x-intercepts, I know it hits the x-axis, and it's positive from -4 to -2, which means that it's got to be above the x-axis. Now this could have been drawn like this. This could have been drawn like this. This could have been drawn like a sharp edge and then come back down. It doesn't matter because as long as these conditions are fulfilled. Okay, so I'm going to stick with this guy. And as soon as I get past -2, it looks like, well, at -3 it needs to decrease. So it looks like -3 is right here at the top of the hill, and it looks like he is decreasing there. So he is decreasing. I got kind of lucky there. And he's going to keep decreasing until we get x equals +1. Okay, so there's 1. Okay, so he's going to keep decreasing. Then, do I have everything? Positive, decreasing. Yeah, these are all the conditions. So all I have to do is now draw something where my domain is actually -5 and 5. So I've got to have something. All right, so I'm just going to go ahead and draw a little curve there, and why not just draw a sharp point right here to +5, and I'm all set. Okay, this guy could have looked like anything else. This guy could have, nope, then he would be positive. He can't do that. Okay, so it could be kind of any kind of graph that would get to +5. All right. All right, then positive 10. Number 10. Jeffrey is emptying a 50 cubic foot container filled with water at a rate of 0.5 cubic feet per minute. Find and interpret the key features of the situation. Well, there's all kinds of key features, right? Let's graph what's happening. And we practiced this for a couple days on Desmos, where, you know, we start off, we have a cup full, right? So we have a container full. It's 50 cubic feet, okay? And it's full, and it continually decreases at a steady rate of half of a cubic foot per minute. All right, so this guy's going downwards. Okay, now he's going downwards, and what I have to do is I have to think if he's dropping a half for every minute, that means he drops a full cubic foot every 2 minutes, which means that 50 will not be halved; it will be doubled. Okay, which means that at 100 minutes. This thing is finally going to be emptied, right? Because every 2 minutes he drops, so every 2 minutes, 49. 2 more, 48. 2 more, 47. So it takes 2 units each time for it to drop a full cubic foot. So this guy has all kinds of key features. I mean, the key features is we have a y-intercept of 0, 50. We have an x-intercept, or a 0, at 100, 0. We see that it is decreasing over the interval 0 to 50. We see that it has a, oh, sorry, I did not put that there. What else? What are key features? It's linear. we see that it has a slope of negative 0.5 cubic feet per minute. What else? That's pretty much it. Oh, the domain. Okay, the domain is from 0 to 100. So here, these are the points, and here, this is actually the domain, and we did include that. And our range meant that we started at 0 and went to 50. So those are definitely key features of that graph. Okay, but you had to kind of like think about the situation and see those key points. Once you got the key points, you could then think, okay, x-intercepts, y-intercepts, domain, range, increasing, decreasing, positive, negative, linear. I mean, this is all positive, right? So the whole thing is above the x-axis, so the whole domain is positive. You could have put that, okay? So those are the key features. So keep that in mind on tomorrow's test.